Alright, so these notes cover factoring trinomials using the box method. Okay, so you guys have expanded and multiplied trinomials using the box method, but we actually haven't broken them down using the box method. Okay, so hopefully they make sense. All right, so one of the first things that we need to talk about is this idea that a trinomial looks something like this. This is the order that we want to make sure our trinomial is in. The x squared is always going to come first, the b is going to come second, and then the number comes last. If it's not in this order, we need to rewrite it in this order for it to make sense. One of the things that I wanted to point out to you too, and I don't know if you've noticed it, is that A, B, and C are all numbers. Okay, A, B, and C are all numbers. Okay, now sometimes it might look like we don't have an A value, but it's because it's an understood one. Okay, but usually we're always going to have a number, and the box method is really fun in order to factor these out. And just as another reminder to you here, oh, that wasn't what I wanted. There we go. If our last term, so if C is positive, then we should have factors in the parentheses that have the same sign as the middle term, as B. Okay? So if we have a plus C, then we should have the same sign as the middle term, or our B value. And if our last term is negative, so if we have a negative C, then we should have different signs inside our parentheses. So we should alternate a positive and a negative. Okay? Skip this one entirely. Okay? So we're going to look at how to factor when the first number of our trinomial isn't the number 1. So the first thing that we're going to do is remember that we have ax squared plus bx plus c. Okay, so the first thing we're going to do is draw our 2x2 box. Okay, so that's always going to be step 1. Step 2 is we are going to put ax squared in the top left box. So ax squared is going to go in that box. Okay, our C term, so whatever number we have is going to go in the bottom right box. Okay, then we're going to multiply our first and our last term together. Once we multiply those terms together, the ax squared and the C term together, what we're going to do is we're going to put x's in our remaining boxes, because we know that those two boxes have to have x's in them. And then we're going to look and find factors of our multiplied term that add to our bx term. And whatever those are, we're going to put in the other two boxes. Then we're going to find the greatest common factor of each column, and then the greatest common factor of each row. Okay, and that's going to tell us what our factors are. Okay, so we'll find the greatest common factor at the top, greatest common factor on the side. Those are the two factors. Okay, so let's one. We have 7m squared plus 6m minus 1. So first thing, we're going to go ahead and draw that 2x2 box. After I have my 2x2 box, we're going to go ahead and put our 7m squared in the top left and our minus 1 in the bottom left, or the bottom right. And I know that I'm going to have an m and an m. Okay? So now I'm going to multiply our first and our last term together. So 7m squared times negative 1 is negative 7m squared. Okay, but I'm only going to focus, and I'm actually going to erase it, I'm only going to focus on the fact that it's negative 7. Okay, so I need two numbers that multiply to negative 7, but add to 6. So I know that there's only actually two possible ways this could work. Negative 1 times 7 and negative 7 times 1. Only one of these, when I add them together, gives me a positive 6, and it's this one right here. So we're going to go ahead and we're going to negative 1 and 7. Now, does it matter which one we put in there? No. Or which order we put them in? No, it doesn't. So I'm going to go ahead and look at my first row. Okay. And I'm going to highlight it in purple here. What do they have in common? They both have a 7m in common. And then I'm going to look at my second column, the negative 1m and the negative 1. Those both have a negative 1 in common. Now I'm going to look at my top row. They both have an m in common. I'm going to look at my bottom row. Looks like they have a positive 1 in common, because that's the only thing. When in doubt, if it doesn't look like they have anything in common, they most likely just have a positive m. So now that I have the things that are on the outside of my box, those are my factors. 7m minus 1 times m plus 1. Okay, and if I were to distribute and factor and FOIL, then I should end up with the original question that we had at the very top. Okay, let's do another one. 3n squared minus 16n plus 20. So draw my box. Okay. In that upper left, we have a positive 20. And just as a reminder, that last term is positive. So that means one of these should be a positive something n, and the other one should be, oh no, they both should have the same sign as whatever the one in the middle is. So they both should be minus n's because the term in the middle is negative. Okay, so I have my box filled out to the best of my ability. And so now we're going to take A times C. Okay, so 3 times 20 gives me a 60. Okay, so I'm going to figure out all the different types of numbers that I have that when I multiply them together give me 60. And off the top of my head, I'm drawing a blank to all the numbers that multiply to equal 60. So I know 1 times 60 does 2 times 30, 4 times 15, 5 times 12, 6 times 10, and I think that's it. Okay, so I'm going to go down this list now, and I'm going to figure out which ones actually add up to, well, hold on a second. These all add up to a positive 60, but I know that both of my terms here inside the box have negative numbers. So that means I'm just going to go through and make all these numbers negative. Boom, 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 boom. Because when I multiply all these negative numbers, we know that 2 negatives equal a positive, so they're still going to equal a positive 60, but now I'm going to go through and see which ones actually add together, so we're going to add them together to see which ones actually equal negative 16. Negative 1 plus negative 60 does not. Negative 2 plus negative 30 does not, does not, does not. Only option. So let's go ahead and fill in our table. So that's going to be a negative 6 and a negative 10. So looking at my columns from left to right, the first thing I notice about my first column, the numbers, they don't share anything. 3 and 10 don't share anything, but they do have an N in common. My second column, there's a 6 and a 20. So if you're unsure about greatest common factor, remember you can go to math, number, go down to 9, type in 6, 20, and it'll tell you the greatest common factor is 2. However, this first box is negative, which means we have to pull out a negative 2. Okay? So now we're going to look at our rows. Okay, the first thing I notice about the rows is there's a positive 3 and a negative 6. They both have a 3 in common, and they both share an N. And in my second row, both are divisible by a 10. However, the first one is negative, so I'm going to pull out a minus, and that's it. So I have one factor and another factor. So if I write these out, we have 3n minus 10 times n minus 2. And that's my final answer. Okay. And I think I have a few more. Right, 2x squared minus 3x minus 5.
Sure. I be being a little baby. This shit funny.
Ignore him, ladies and gentlemen who are listening on YouTube. So I have a 2. Oh, hey, that's not a 2. 2x squared there, minus 5 here. Because my last term is negative, I know that the signs inside the parentheses are going to be at least one positive and one negative. I'm going to go ahead and put the x's there. So let's go ahead and do our multiplication of 2 times negative 5. Okay, which gives me negative 10. So two numbers that multiply together to equal negative 10. So negative 1, 10, negative 10, 1, negative 2, positive 5, and negative 5, positive 2. And let's go ahead and see which ones of these add together to equal negative 3. Not this one, not this one, and not this one. So it has to be that one. So I'm going to go ahead and plug it in. So negative 5, positive 2. Okay, so let's go ahead and fill out our factors of our box. First column, the only thing they have in common seems to be an x. In the second column, it appears nothing in common. So because it looks like there's nothing in common, we're going to do a plus 1. Okay, now we're going to look at our first row. They have a 2x in common, our greatest common factor. And then in our last row, there's a 5, but because it's negative, we pull out a negative 5. Okay, so our two factors are 2x minus 5 times x plus 1. All right, and then the last